So today is not terrible. Today is more of a review of anything, of transformations of functions, right? So in Algebra 2, every single section, we had transformations of a function, correct? Did the rules change for the sections? No, it stayed the same every single time, okay? Your K value is what you're adding or subtracting, and it's going to cause your function to go up and down, right? Your H value is attached with your X, and your X is a what? Liar. X is lie to us, okay? So even though it says minus H, we're actually going to the right. It says plus H, we're actually going to the left because our X's do the opposite. Okay, when you have your A, that's a vertical dilation, which just basically is what we called our stretch and our compress, right? So back in Algebra 2, we called it a stretch and a compression. And pre-cal, they call it a dilation, okay? If you think about, and back to geometry, isn't a dilation when something gets big or small, correct? Yes. Okay. Your G of X, your F of B of X, B times X, that's your horizontal dilation. That means you're changing your X value. Oh, factorial. Oh. So here we go. So your A, again, if it's negative, that's a reflection over the X-axis, correct? Your B, if it's negative, it's a reflection over the Y-axis. And again, X's are liars. It looks like I'm multiplying to my X, but what am I actually doing to my X's? Dividing. X's are liars. So it looks like you are multiplying, but you're actually dividing them, okay? All right, what's the purpose of this? Well, the transformation rules are basically a quick shortcut way to try to sketch any parent function after transformations. Okay, so with that understanding, we have to remember where the parent function starts. So for this, you should have like a little space in here where we're going to draw our parent function of the rational function. Yes, you do, right? Yeah. Okay, so this is just our XY plane. Okay, our parent function for a rational function. So we're doing f of x equals 1 over x. That is the smallest form of rational function you can create. Does that make sense? Okay, it's still rational because I have a variable in the denominator, and its parent function. Your significant points are 1, 1, and the other one is at -1, -1. Okay, the other significance here is that it has a vertical asymptote at x equals 0, and it has a horizontal asymptote at y equals 0. Because of these asymptotes, from those points, I'm just following the asymptotes. Does this sound familiar about your rational parent function?
Is this what the test was about? Like this exact thing?
Kind of. I mean, about knowledge, but.
Yeah.
Okay. So because of this is our setup for our parent function. Agree? Everyone looks familiar? Okay. Now, because of this, there's significance to our H and our K. Okay. Your K, that's going to affect your horizontal asymptote. So your K is always going to be your horizontal asymptote. So this is our horizontal. When in this format, your H is going to be your vertical asymptote. When it's in the transformation form, your K represents your horizontal asymptote, and your H represents your vertical asymptote. Make sense? Okay. Yes. Are we ready to just see this all in play? All right. Here we go. So first up, we have f of x equals 1 over x plus 2. Okay. So from here, we're going to identify our variables. So we just summarized that we have, I'm going to write the summary. When we are in this form, 1 over x minus h plus k. Your H represents your vertical asymptote and your K represents your horizontal asymptote. So with that in mind, when I look here without doing any real math, I know that my horizontal asymptote is where? At 0 because he's invisible, right? So I have a horizontal asymptote at 0. And I have a vertical asymptote. My X is a liar, so it's not a positive 2, but a negative 2. Yes. Yes. But if all those fails, this is the shortcut using the transformation. Yep. Don't lose any of that prior knowledge. Keep all that going. Okay. Next is your points. So what were our significant points? Our starting points were at 1, 1 and -1, right? So I'm taking these points and am I shuffling them up? No, I'm only shuffling them to the left 2. Does that make sense? Yes? Yes. Which part did you ask? I'm sorry. Okay, so I'm gonna get my pen, got my new, whoa. I'm on a different page. So we're gonna shuffle to the left twice. So here's your new home. Here's your new home. And all I'm doing is following the.
Oh. So our new.
This is pretty easy.
Yeah. All right. So that's the basics of it. How do you feel about the basics? Okay. All right. Now, B is an example where we have an A in play with us. So B is in the format of A over X minus H plus K. Okay. Your A is going to affect your Y value of your original point. Okay. So what happens here is that we're going to, our Y's are being multiplied and shuffled. Why? Because we know that A equals 2, our K equals 3, and our H equals what? -1, because X's are what? Liars. It's not a 1 anymore. I mean, your A is 1 technically, but it doesn't make any difference or change to the function.
Oh, I was gonna ask that.
Yeah.
Right, doesn't know where to read.
Until it changes value? No, it doesn't. All right, so from here, we know our asymptotes. Where are our asymptotes? We have a horizontal. Where though? Our horizontal comes from our 3, our K. So we have a horizontal asymptote at 3. So here at Y equals 3, we have a vertical asymptote, which is based off of our H at -1.
How do you find the horizontal asymptote by using
Degree?
the degree? Yeah.
Yeah, but if you,
If we're in, yes, I said, do not forget all of that. But if we're in transformation form, all you're doing is using the fact, I know what H and K does to my function.
How do you differentiate the two?
So this is transformation form because you're adding something onto it, right? It has unlike variables. I can't combine them. If I was to take this out of transformation form, detour of notes, here we go. I have 2 over X plus 1 plus 3 over 1. I would need to rewrite this, so it becomes 2 plus 3x plus 3 all over x plus 1. So not in transformation form, this would be 3x plus 5 all over x plus 1. And that would be.
Yeah.
yeah, the degree is
Wait,
equal to
so how do
zero.
we know that transformation form on the first one?
Because of the format. So your parent function starts off as f of x equals 1 over x. And all I'm doing is manipulating that x. So from my parent function, I can subtract the x, I can add the k, I can multiply by the a, right? That's because I'm transforming the parent function. All right, so this is written in transformation form. This is just a traditional rational function, right? And from here, you would tell me, oh yeah, your numerator and denominator degrees are the same. Your horizontal asymptote is at 3. Agree? Is it at 3?
Yeah.
Yes. Here, oh, your denominator has x plus 1. X can equal -1. So you have your vertical asymptote at -1. Okay. And that's just the gist of it right there. As far as the difference between this and that is just one requires maybe sometimes a little more work to evaluate, and the other is just knowing the pieces and being able to say what they do and what they mean. Okay. All right. So next is our point. So our parent function points are originally here at 1, 1 and -1. Right? Now, I know I have to shuffle them, correct? But what also is affected? Huh? It's also stretched, right? It's stretched by a factor of 2. So my function's also stretched by a factor of 2. Who does that stretch affect? My x or my y? The stretch affects my y. So to each one of my x values, this is what's happening. So for x, all it's doing is subtracting 1, right? Because I got to shuffle it to the left. So my x is -1, but my y's, I'm doubling and I'm adding 3. Does that make sense? Because a is what? A is 2 and k is 3. Yes.
So your little blue points, are those always gonna be 1, 1? and
Yes.
-1,
Your parent function points are going to always be 1, 1, -1, -1. Yes. Always. Don't move. Same thing since algebra 2. They haven't moved.
I don't remember anything about it.
I know. It's okay.
I remember this.
I got it. All right. So I'm affecting these points by following this rule based on what these are. Does that make sense? All right. So x's are going to do what? Go to the left 1. So my new x's,
Never mind.
I don't want to do it because I want to like write it out. Is that cool? I'm going to do the math, but not move the point. Or will it bother you if I don't do it step by step?
It doesn't matter, miss.
All right, I'm just gonna do the point. So we're at -1 minus 1, right? And then 2 times -1 plus 3. So where is the new home of -1, 1? -2 what? It's gonna be a -2 positive 1. Oh, that basic math. Y'all are concerning my soul.
Over 2, less 2.
Yes?
No, 1.
We did the -1, -1 first.
Oh, you're doing the point. Oh.
Yes, so we moved -1 first. And where did it move to?
Still doing the same thing.
We did the same thing. We just couldn't shift because we have an A value. We have a dilation.
Wait, so is it supposed to curve like that, or is that just your drawing?
It's my drawing.
Really?
It's my drawing.
Yes, it is.
Pretend that this is the most curvaceous situation.
Oh, it's like curve. It is it curving or is it straight line?
No, it's curves.
You think
It's
she's
question.
gonna draw a straight line? Maybe her also.
I think someone brought you the food.
That's just not count.
You don't remember me? My notes are similar today. Oh.
Wait, so you only have to do 1 point?
We're gonna do the other one, but someone criticized my graph.
I bet.
All right, so the other one. What happens with 1, 1?
Wait. 0,5.
0,5. So we're at 0, now we're at 5. Annabeth, can you tell them why we're at 0,5?
If you plug in 1 and 1, each of these. Like you plug in the 1 for the x and the 1 for the y, so it's 1 minus 1 is 0 for the x value. And then 1 times 2 is 2, plus 3 is 5, so the new point is.
Yeah.
She said the right answer. Why would I then? Why would I have her explain the wrong answer?
Basically, those 2s and those 3s get added. Thank you.
Thank you. Yeah.
Yes, except it didn't correlate in my brain.
Okay.
Is that what we're doing? The red?
Yes. So a lot of this is supposed to take place in your brain, but because of its notes, I'm having to write it out for you. Does that make sense?
Yeah.
This is meant to be like mental, boom, 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 shuffle, move, go on. Okay. But I just want to make sure that we understand what's in my brain because, yeah, we're okay. I'm gonna now give you one to do. Are you ready to do C at your table? Yes, you are. I believe in you.
I already did it.
Okay.
Get rid of it.
Oh, you need me to go back?
Yes.
We're just walking through it. real
Okay.
quick.
Well, you're doing C at your table.
We can do D together.
We're gonna do D together.
That's right.
Which shows, where did we get that red equation? No, it's blue. But I don't, that blue equation.
From using what your A, your H, and your K are.
Oh, it's X. So our first step is find A, H, and K.
Yeah. Yes, what's your A, your H, and your K? Oh. So your A, and what is your A? On C.
Oh, we're not there. So I'm not there. Okay, we're A on, our A on C, is one negative one,
Yeah, okay.
right?
Yes, your A is -1. Yes.
Like, it's 2, like, K is what? K is 2. No, it is, it's positive, it's 3.
That's our answer.
That's as far as I can go. So then, guys, so then your K.
So your A and your K affects your Y. Right? Your A and your K affects your Y. Agree? Y'all got that? Your H affects your what? Your X. So what?
Wait. Can I write
What
that
you're
down?
asking?
Yeah, wait. H is 3. Okay, but it's not, that's not the point.
Nothing. I just said,
Your horizontal fix up where they A is your.
Yeah. Okay, yeah, that's right. Yeah, but you said.
No, A and your K affect your Y. A affects Y.
So those are our.
So your K is your horizontal. Your vertical is 3. There we go. Do you have those at least?
Yeah.
Your horizontal is your K. What is your K?
2.
Yeah.
What about the -1?
We're gonna use it.
Two
Negative.
minus
Gotta
one.
use it, Jay. We're about to use it, but can you put your asymptotes first?
Yeah.
Your ass is so our B.
Yes. Yes. Do we have the asymptotes?
Yeah.
Okay, now we're on to moving. Remember, our parent function is always negative. There you go.
I said that, I did that.
It's at -1, -1, 1, 1. These tell us how we're moving those points. Okay, your x's is 3. So to each x value, I'm going to add 3. Okay, your y is affected by your A and your K. Oh, sorry. Sorry. These are your parent functions, your set points. Those are always there. Okay. Your y is affected by these two. So my y is gonna be multiplied and add 2. Because my A I multiply, which is what it says up here. Your A, you are going to multiply to a factor. That's gonna make it see the factors.
So it would be safe to say right.
So what are your new points following these 2 rules? These are called transformation rules in geometry.
So it moves 3 to the right.
Uh-huh.
So it's safe to say that that's our equation.
It moves up and it stretches and reflects.
It's just 1, 0, 3.
Just like a little bit. You raising your hand?
Zero down.
Why?
Zero.
Just plug
I don't understand how you
Is
do
your
it.
Y?
What, with that? I
Your X and your Y.
mean, you don't have to do that.
Right, every time.
I next one, next one,
So as long as I figure how to get.
So what does that mean?
So you're.
Look at what she did.
Three, right?
Oh,
And then
yeah.
you get-
Yeah.
You look into it, right? Or you move your watch.
I do that.
And one plus the one.
I said that, I said right.
So what is
I'll go
it?
next.
Negative one plus three is what, James?
I moved to the right 3 times.
But you're moving three down, three this
Yeah.
way and two down.
But it only
No,
puts
no,
that
no.
two, it doesn't put that three where it's like. Because you're not at zero, sweetie. You're at negative one.
So that would be a positive one.
This makes sense.
I mean, you wrote it last year already. It would be four of how you're moving these points for this problem.
So
These,
we're.
you're moving
Three
the
this
same way.
way.
You're reflecting.
Okay, yeah.
Same way. So you don't, well, you do to one point, you do to the other. Okay. I can't get that.
Yeah, I don't know how to text.
Man, when you get up, you see that talk about
Why is it reversing for the other one?
reversing.
Yeah.
No, just plug in the values.
What are you doing, Jay?
What are you reversing? All right, here we go. So on this one, our A is -1, agreed?
Yeah.
Our H is +3, and our K is 2. Yes? So that means our vertical is at 3. Our horizontal is at 2. My X values are going 3 to the right, which means I'm adding 3 to them. Agreed? But my Y values are being multiplied by -1, and then I'm adding 2. Does that make sense? On which part?
In the previous one, you explain how to get
Yes.
there?
So the best way to, guys, let's write it like this. I'm gonna write it how Rin wrote it on her paper. She wrote it as X minus your H, and it's gonna be A times your Y plus your K. I'm sorry.
And it's always that way. Okay.
Does that help?
Yeah. Is it? Is it with the X and liars thing? The
Well, you already fixed the lie once you say what your H is. So you've already corrected the lie once you've identified it. Mhm. So like here, we already said that this was X plus 1, so we knew H was -1. Yes, does that help? Okay, all right. So each one of these points, so I know that it's in my mind, I'm doing X plus 3. And to each one of my Ys, I'm multiplying by a negative and adding 2. Agree? Anyone's like, I don't know what you did. So where are my new points?
2, 3.
So I'm at 2 and
3. Wait. And then 4, 1.
so this is what your graph should have looked like. Pretend that I didn't touch the asymptote. You see that, you don't see that, okay? I just got really close to it. Yes,
Oh, yeah, so.
I just got really close. Okay, yes,
Oh, okay, I didn't.
looks like we're gonna do D on our own. Well,
These are easy.
D's it's not that bad.
It's easy.
You just gotta factor first. Okay, all right. If you want to try D before you do anything, you just gotta factor it first to separate your A and your B and your H.
2 times X minus 2.
There you go. So it becomes 2 times X minus 2 minus 3. So now we have an A, a B, a H, and a Okay,
It's an X on that. Yeah, and then, or X minus two is denominator, because like, it's then equal to zero.
yes, but I'm showing you why it works as well. It's still in the same format.
It's one over X minus two, right?
Yes,
Okay.
but with, because that's what it originally is before the transformation. Yes.